Hello everyone. So today at lunch you will be taking your spectrometry measurement. There's a few things we need to review before you do that. All right, the algae that we're growing in the lab for this project is called Chollera Vulgaris, and this is a unicellular plant cell. So they actually look like this, and if we review your bio class, there's a cell wall made of cellulose, but there are tiny organelles here which are called chloroplasts. And these are the organelles that really interest us because inside the chloroplast there are a bunch of thylakoid stacks, and inside of these thylakoid stacks basically there are pigments. Now most plants have three types of pigments. The first one is chlorophyll, which is green. The second one are carotenoid, which are orange, and the third one are anthocyanins, which are red. Actually this is why your carrots are orange. It gives it the orange color, and if you break this molecule into two, you get vitamin A. All right, so it's the foundation of beta carotene. All right. Now, three types of pigments. Now, why is this of any interest to us? Well, over here, this is the electromagnetic spectrum, all right? As you can see here, waves here are very, very big and do not carry a lot of energy. Now, as we go down this way, waves, they get smaller and smaller and smaller, and they do carry more and more and more energy. Now, out of this spectrum, there's only a tiny bit here that our eyes can see and that plants uses. This color here, the violet and blue, has lots of energy, so you're going to see that the plants really try and absorb a lot of this light. Green is not really absorbed by plants, and then red and orange will be absorbed by plants, all right? Now, as a reminder here, most plants are green because light shine on it and absorbs every single color except green. Green's being reflected, and that's why plants appear to be green. Okay. Now, over here, if we look at chlorophyll A, chlorophyll B, and carotenoid, you see that these three types of pigments, they really try and absorb as much as they can from the high energy light, which is violet and blue. Over here, you see that green is not being absorbed by any type of pigment, and then chlorophyll A and B do absorb in the red-orange color. The measurement you're going to be taking at lunch today is at 660 nanometer, which is right here. This is the peak absorption rate for chlorophyll A, all right? And this is why you're taking a measurement at 660 nanometer. It is because it is the peak absorption of one of the pigment. Now, how does a spectrometer work? Basically, there's a light, which is white light. It passes through it, all right? And this is your cuvette where all the algae is going to be in. The algae will absorb, chlorophyll A will absorb red light, basically. And then the rest will be shining up to a detector. Now, the machine will give you a number, and the number is a ratio of incident light divided by red light, all right? And it's an indication of how well the algae is growing. So the more light is being absorbed, we can conclude that the more algae growth we have. Okay, to take your lunch measurement, you will be needing Logger Pro in your computer. So bring your computer, open Logger Pro, which is the software you've used in chemistry. Connect the spectrometer, which is available on the table in the physics lab. And then basically what you're going to have is you should have like a spectrum of colors appearing here. All right, if you click on that button, what you're going to say is you're going to come and click here, all right? That you want the spectrometer to take a measurement at 660 nanometer. Now you might not have the 0.2. Take the closest value to 660. All right. We don't need any units here, so you remove it, and then absorbance versus concentration, and click OK. Now you're almost all set of measuring, but before that, you need to calibrate the spectrometer. This is basically like doing a zero on a balance before taking the mass of an object. So over here, you're going to go experience, and then calibrate the spectrometer 1, okay? Now, before you do that, you have to put the neutral, the growing medium solution into the cuvette, and I'm going to show you this in about 5 seconds how to do that. But once the cuvette is filled with the growing medium, which is the neutral, you're going to calibrate this stuff, okay? And then you should be ready to take your measurement. Do not forget here that when you calibrate, okay, there's a 90-second wait. You cannot skip this preheating. This is the light. The light, when you turn on the spectrometer, the light needs to heat up and so it can attain the right frequency. If you skip the preheating, the lamp preheating, the thing will not be calibrated correctly.
Okay, let's review a few steps here on how to measure the absorbance. You're going to take a micro cuvette. Now be careful not to put your fingers on the side. The grease from your fingers can alter the side. You can actually even take a wipe here, even if these are brand new, clean and sterile. You're going to clean them, all right? That is garbage, okay? Now do not put your fingers here when it's been cleaned, all right? Now, on the side of the cuvette, there's a tiny arrow. You probably don't see it, but it's a tiny arrow in the plastic. This arrow needs to go with the arrow that is right here, all right? Like that. Cool? Then, what you have is, you have your micro pipette, which is set at 1 ml, right? That's 1 ml. You're gonna open this. You're gonna punch in, all right, and close. Close that, okay? This is all sterile stuff, all right? You're gonna go in, take 1 ml. Now remember, you press down at the first stop, you stop, okay? You take in the liquid. Now, do not, I'm telling you, do not fill your cuvette like this. If there's water or growing medium going around and inside, you're gonna ruin the lamp and ruin the device, okay? So take it on the side, and then you can press up to the very bottom here. Okay, one more time. 2, and then one more time. 3. So I now have 3 ml, all right? Now I can actually, the arrow with the arrow, put this in, and you are now ready to calibrate the spectrometer as I shown in the video just before, okay? When the thing has been calibrated, okay, the tip here that you've used for the growing medium need to be discarded. You cannot use the same one to measure the algae. If there's a tiny drop, you're gonna dilute this and the measurement would be incorrect. So you need to discard the tip, okay, and you need to take a brand new one. I know it's a lot of waste, but if we want accurate measurement, that's the way to do it. So you take a brand new one, okay, this is done, okay. You take the cuvette with the growing medium, you can discard it, okay? There should be a tiny beaker where you can put all your waste, and then you start all over again, all right? Open the algae. Be very careful with our babies here not to spill anything over. You take a new cuvette, you take a piece, you clean it correctly, you do not put your fingers, all right? That is garbage. Now the arrow needs to go with the arrow, which is like that, okay? And once again, you're gonna be taking algae, all right? So one stop, I go in, be sure you stir the algae. The algae should be on the stirring platform anyway, okay? Take the cuvette, fill it with 3 ml, you put it back in, and then you can go and take your measurement.